Hello everyone, thanks for watching this video. My name is Yaji Zhang and I come from University of Chinese Academy of Science. And today I'm going to talk about our solution for YouMakeup weekly challenge. And the YouMakeup weekly challenge is introduced for fine-grained action understanding in makeup instructional videos. And there are two tasks in this challenge: image audience task and step audience task. Both tasks are based on the YouMakeup dataset, and we will talk about the two tasks separately. First, let's talk about the image audience task and our solution for this task. In image audience task, there are 5 images extracted from each video that have different steps and corresponding makeup step descriptions. Our model needs to sort the 5 facial images into correct order according to the given step description. The visualization of one sample data is shown as the first picture. There are 5 given images marked as lowercase a, b, c, d, and e, and for this video there are 7 steps. The step descriptions are shown as this. For example, the first step is apply primer on your face. The second step is apply foundation on your face with beauty blender. As a weekly task, for each question there are 4 candidate answers provided. We marked them as uppercase A, B, C, and D. Each of the candidate answer is sort of the 5 images, and only one of the candidate answers is the truth. And the second picture shows one sample data in JSON format, and there are question at the video at step caption, ground truth, and candidate answer. The ground truth is used for evaluating the validate accuracy, and for this task, the task set and the candidate is provide images, but for training set we need to extract the images from YouMakeup datasets by ourselves. And the YouMakeup dataset is consisted of videos and step descriptions. Each videos has about 10 steps on average, and for each makeup step descriptions is aligned with a video clip. To build our training images, we extract exactly 10 frames at the end of each video clip. In other words, we extract 10 frames at the end of each step, for the data pre-processing method described in YouMakeup baseline paper. Specifically, after the duration of a video clip is less than 10 seconds, we extract 10 frames consecutively backward from the end of the clip. Otherwise, we extract 10 frames with a gap of 5 frames backward from the end of the step. And finally, we generate some images for the training set. And for this task, directly predict the order of the 5 images is very hard, and it's very hard. So we want to simplify this task to pairwise audience task. In other words, we want to get the order of each pair of 2 images, and then we can construct the answer of the 5 facial images order. Our model is shown as live. shown as this picture. The input of a model is two images and the corresponding video step descriptions. First of all, our model will extract the features of images and text, and then concat the features is fit into a binary classifier. The predicted binary class indicates whether image I is before or after image J. And for a feature to contract the image pair input for our model, as described before, we have many images in each step, and then we randomly select two images from two makeup steps in a video as an image pair for the input, and also we balance the classification level of the when we construct the input. And also need to mention our feature, the feature extractor of our model. For the image feature extractor, we use ResNet 18, and for the text feature extractor, we use bidirectional GRU, and also need to mention, due to the large size of YouMakeup dataset, we use the YouMakeup dataset is about 100 GB on this disk, so to simplify this, we directly use the pre-computed ResNet 18 feature provided by the baseline paper, and then when we train our model, the feature extractor for images is not exist, and for this task, the evaluation matrix is accuracy. This table shows the validate accuracy and test accuracy of the baseline model and our model. The baseline model is the image pairwise compared model, which is described in YouMakeup baseline paper. The baseline model is just like our model, but without the text branch. And this table shows that the text branch is certainly helpful for this task. And then let's talk about the step-oriented task. Different from image-oriented task, the step-oriented task is to sort 5 given step descriptions for video. One sample data is shown as the first picture, the visualization. It's a visualization, and there are for this video there are 5 given step descriptions. Actually, there may be more steps in the video. It's just the chosen 5 steps, and we marked the steps as lowercase a, b, c, d, and e, and as we call it challenge. There are for each question there are also 4 candidates on the profile lead. We marked it as uppercase a, b, c, and d. And the second picture shows shows an sample data in this format. There are question ID, video ID, step caption, and ground truth and candidate answer. The ground truth is used for evaluating the validate accuracy. And different from the image-oriented task, there are have video features but without image features. So our model like the image, the model, the solution used in image-oriented task. We formulate this task as a pairwise oriented task, and our model is used to predict whether sentence I is before or after sentence J. Our model takes a video and two sentences as input. After extracting the features, we concat them and then feed into a binary class file. To the predicted binary class indicates whether sentence I is before or after sentence J. And also need to mention, due to the large data size of the videos, and we directly use the pre-computed video features provided by the baseline paper, and so in training, the video feature extractor is not exist. It's not exist, and for this text, the evaluation metrics is also accuracy. As shown in this table, we calculate validate accuracy and the test accuracy for 4 models. The text class field and the CDM plus model are described in YouMakeup baseline paper, and our image text class field is shown as before our model architecture, and the comparison of our image text class field with text class field shows that the video feature is certainly helpful for this task, and our final model is an ensemble of the 3 models, and our final validation accuracy and test accuracy is the second place on the test leaderboard. And then, to summary, I think there is still many things can be done for further improvement. For example, a better feature extractor like bigger resonance may lead to better performance. For example, for the image-oriented task, we use the image feature extractor is used as resonance 18 is used as the image feature extractor, which is if we replace it with a bigger resonance, the performance may be improved. And also some other features like audio may be also helpful. Audio which can be extracted from videos is easy to access in the cyborg task, and also need to mention And also need to mention for the 2 tasks the training, we use the pre-computed features, and maybe end-to-end training is more helpful, and thanks for listening. That's all. Thanks.
Hello everyone, I'm Lu Dan from Renmin University. Due to the personal reasons of the winning team, they are sorry to be absent from this meeting, and I will introduce their methods instead. The team members of BUPTMM are Kun Liu and Huadong Ma. Both come from Beijing University of Posts and Telecommunications. Their final model reaches 85.19% in step ordering task. Now, I will introduce their method. They use 2D temporal adjacent network as base model, which is received by AAI 2020. The base model obeys the structure of feature extraction, feature fusion, and matching score prediction. For more detail, please refer to the original paper. Then, based on it, they make adjustments in the model of matching score prediction by channel attention. In specific, after obtaining the multimodal representation, they first shift the length of sentence embedded into the channel numbers of the multimodal representation, then employ the sentence embedding as guidance to generate the channel weight alpha of the output channels for a fusion feature map. Finally, a normalization operation is conducted to avoid overfitting. In this way, alpha can offer valuable guidance to the moment retrieval since it is derived from the sentence embedding. Moreover, WM is a shared parameter which is computationally efficient and only involves a handful of parameters. For experiment, it contains two parts: the evaluation of moment retrieval method and the evaluation of the ordering task. Firstly, they compared moment retrieval performance with other state-of-the-art models. We can see that their adjustments boost the rank first at IOU equals 0.5 from 37.33% to 41.74%. Besides, their method also outperforms all baseline models with the same I3D visual feature. Secondly, this table shows the evaluation of the ordering task. The former 4 lines show the performance of single models. The last 4 lines show the performance of combined models. Interestingly, also, their model can localize moments more accurately. It obtains a lower accuracy than baseline model SCDM+. Besides, fusing multiple models can improve performance significantly. The fusing method is to compute the sum of multiple models' distance and select the candidate with the shortest distance. The result shows that the way combined 4 models, SCDM, SCDM+, 2D TAM, their model can achieve 85.19% classification accuracy. Thank you.